Hello, my name is Leaf. I am a student at Champlain College. This will be the second video that I'm putting up and the first video with an audio voiceover. This video will be accompanying a tutorial that I have on my blog at leafnode.com. If you have any questions, just comment below and I'll try and answer them. I will be showing my current tech demo of Flowfield Pathfinding. Flowfield Pathfinding uses a cost field to model terrain that units can path through. The major advantage to it is you can have thousands of units pathing through terrain at once, and all of them can have their paths manipulated in real time without having to recalculate any paths. So it's really useful for things like RTS games. In advance, I apologize for my really depressing tone. I'm just working on that. Alright, calculating a flow field can be broken down into three major steps. The first step is calculating the cost field, the second step is calculating the integration field, and the final step is calculating the flow field based off of those. So what I'm going to show you first is the cost field and its representation. The cost field is what is responsible for telling the integration field what parts of the map are actually reachable. So I can paint walls here that units will not be able to cross and they will avoid. I can also paint areas of higher cost that the units will try to avoid, but if they have to, they can go across them. I'm going to load a map in that I had made earlier. So this map has a few bottlenecks. So if units path from this area to this area, they'll have to go through this bottleneck and they will converge a little here. The same goes true for this, but they are forced to converge here, so extra units end up getting stuck on the edges here. The collision detection that I have in place is very rudimentary, so they get kind of stuck on there for a while. After this, the integration field uses the cost field in order to calculate the paths. So I'll show you the integration field now. This is what I have the integration field looking like. The integration field works by starting from the goal point and assigning a cost of 0. And then for every box outside of the goal point, it adds 1 to the total cost and saves that in the box. So 1 out from here is cost of 1, 2, 3, 4, same for top and down. I do not have it calculating diagonals, so what happens here is it's actually a cost of 1 and then 2 to get to this point. This ends up having some interesting behaviors when you have a large number of units because they end up trying to converge here and then go towards this. This is not very noticeable if you do not have a vast area of openness between the goal and obstacles. I can move the goal throughout the map and you see what looks like a light effect sort of. As it gets further away, areas get darker. So over here it is the highest cost because it has to traverse all the way through this area and then up these areas of higher cost that I have here. Same is also true for down in this area. The final step to calculating the flow field takes the results from the integration field, and then for every one of these cells, it finds the cell adjacent to this cell that has the lowest cost. So the lowest cost cell looks to be this one, so I'm going to draw the vectors. And these lines represent the direction that units will take if they are on top of this cell. So this is pointing towards the lowest cost. Same is true for the rest of the map. As I move the goal, all of these are recalculated as required. These vectors are just stored in an array and looked up by index, so it's incredibly quick for units to find the direction that they need to move if they have their location relative to the map. Okay, so now I'm going to show you some units trying to pathfind through this map. The units use the vectors on each cell that they're inhabiting. So I'm going to add 200 units to the map in the top left corner. This is normally something that doesn't work in normal pathfinding techniques, because if you use a pathfinding technique such as A-star, what they will do is go and take the location from each unit and try and find a path to that. So every one of these guys, all 200 of them, would be calculating paths to this. The great thing about this technique is that you can combine other movement techniques with this pathfinding. If you use A-star or Dijkstra's, you are constrained to only following these paths on the dot. So the units will move this way until they get to the goal. You'll end up having units that go like that and then straight with very rough edges. So what I've done here is implement basic blocking behavior. So each of these units tries to move relative to the other units close by. They will try to stay as a pack, but if they get too close they'll also separate, and they'll also try and match their alignment. So you have this large group trying to go in the same direction. They'll still try and follow the path though. We'll go and remake these units again, show you them going through this bottleneck. So this kind of represents flow fields. They do look like a flow of water going through the map when you have a large number of units. You can change the goal dynamically while you're running, and they will automatically adapt. If you hit a part that is unreachable, then they'll stop following their paths and just start flocking. So let's send them to the bottom right hand corner of the map and see what path they decide to take. So it looks like from these vectors they're going to try and go this way. Right here you can see the behavior where they try and converge on the line before going to this. Normally they would go in a straight line like that. And they flow around the corner like that. So this is a basic implementation of flow fields. I wouldn't recommend doing a 100 by 100 flow field in a production game. This is a very large map and it actually takes about 50 milliseconds to calculate the whole thing. So unless you have a system where it's multi-threaded, which is possible since only the integration field should be writing to itself. Unless you want to do something like that, then I wouldn't recommend this. There are more advanced techniques where you have, this was what was implemented in Supreme Commander, where you have 10 by 10 grids, but you have 10 by 10, 10 by 10 grids, and then you do an A-star path find through those, and then calculate the flow fields for each of those that units go through. So it saves a lot of time on that. Alright, so this looks like that's all I need to show you. Visit my blog at leafnode.com, and tell me if you like it. Thank you. Bye.